ready.
All right, are you all ready?
Oh, that last question looks.
Now, yesterday I talked about the chain rule. Today we're going to talk about product rule. And next Monday we're going to talk about the quotient rule. All right?
Yes.
So the product rule. What is the product rule? Yesterday we talked about function inside of a function. Right? So we know that you got y equals to fx or fu, and u can be defined as gx. So when we have situation like this, you know dy dx equals to dy dx equals to u. Oh, hang on, I'm thinking about the product rule now. I'm not thinking about the chain rule. Let me write it down, the chain rule. I'm so used to doing it. When you ask me to write this down, I totally forgot. The chain rule is then dy dx equals to dy du over du dx. Alright? Now today we are going to talk about the chain rule. The product rule, where you've got y equals to fx times gx. Alright? So something like y equals to 2x plus 1 times 6x minus 1. Or could be y equals to 2x squared minus 1 cubed times 6x squared plus 3x minus 2 over x. Something like this. Alright, so we're talking about the product rule and we're going to move it to the next stage. So by the end of the lesson, you should be able to apply the product rule to differentiate simple products involving polynomials, negative indices, and radicals. You should be able to use the product rule to calculate instantaneous rates of change and determine the corresponding equations to the tangent lines to graph. Determine the coordinates of points on graph with specified gradients. Examine simple examples of the product rules from a graph or table. Examine cases where both the product and chain rules are needed for differentiation, leaving answer in both simplified and unsimplified forms. And finally, solve practical problems. All right, now, let's look at the situation. Let's say you're running a manufacturing business and you're tracking the running cost over time. So you know that the cost is actually calculated by multiplying the number of units and with the product P. All right, I am going to define 3 different functions. So CT is the running cost during a particular period time T. NT is the number of units produced during a particular period time T. And PT is the production price per unit. Since we know that the cost is NT times PT, the multiplying the number of units times the production cost, so we can actually use that to look at the rate of change in revenue with respect to C, the cost. All right, so you are going to look at how to derive the first derivative of C. Yeah, that's just an example, just a situation that you need to think about. So now, from modeling, you know that someone you get, if you get someone to do the modeling, you know that NT is actually T squared plus 3T plus 5. And then PT is 1 minus 2T. So now we can see that we've got 2 functions, NT times PT. How do we actually determine the first derivative? In this example, you could actually expand. But really, do we want to?
No.
Thank you. So, we really don't want to do that. What we can do is, let's actually try, can you all work on this problem? Let's expand first and determine the first derivative. All right? Let's expand first. This is the first one. First step I want all of you to do. Try that expand first. see how much time it takes.
Hate expanding.
All right, stop. I'm not going to catch you to waste your time. Stop.
I actually finished.
Let's go to the second situation. All right. Now you can see it's a lot of trouble expanding. Agree?
Yes.
Yeah. I mean, it's like thinking about this multiplied by this multiplied by that. Stop. Now let's define this as two different functions. All right. I'm going to let u equals to t squared plus 3t plus 5 and v equals to minus 1 minus 2t. Can you then differentiate du dt and dv dt, please? All right? Do that. Once you have done that, can you please determine du dt times v and d plus dv dt times u? It's a lot more straightforward if you could do that, du dt and dv dt. Correct? Yeah? Instead of expanding it, you go crazy expanding some of the functions. Because looking at that straight away, you know du dt is 2t plus 3 using your power rule. And v is just minus, dv dt is just minus 2. So can you quickly determine the next one? Since you've got the idea now, you've got what du dt is, dv dt, before I go to the next slide. Right? So, I'm not going to write it out. If I expand it, I've worked it out. Expanding ct is minus 2t cubed minus 5t squared minus 7t plus 5. Alright? Took a while for me to get that. Typing it is easy. And then I can differentiate that. The bit of expanding is a lot longer. Now, if I do it this way, if I assign this as u and assign this as v, so I know du, dt, and dv dt, and I give this to you. I ask you to look at that. When you expand that, it's a little bit more straightforward, and you can see that you're coming up with the same answer. Correct?
Yeah.
Yeah?
Yeah.
So, now, the product rule states that for a function defined as a product of the form y equals to fx times gx, the product rule states dy dx is fx times the first derivative of gx plus gx times the first derivative of fx. Alright? Or basically dy dx equals to v du dx plus u dv dx. That's all. Now for product rule, multiplication and addition are both commutative, so order does not matter. For product rule, order really doesn't matter. However, when we look at the quotient rule on Monday, orders actually matters. Multiplication, gx is the same as gx times fx is the same as fx times gx. Alright? So think about one of them as u, one of them as v. This is what you need to know. Dy dx equals to v du dx plus u dv dx, which is actually in your formula sheet. Alright? So in the formula sheets, I've covered the chain rule and the product rule. let's go on to do some example. So it could be either be in the function notation or in the Leibniz notation. All right, let's try this. Let's try example 1. Determine the derivative of the following function. So looking at this, the first one, I will just dy dx equals to 5 times 2x plus 1 plus 2 times 5x plus 4. v u dx and u dv dx, which is 10x plus 5 plus 10x plus 8. So that is 20x plus 13. Now just doing a sanity check. You know that you're going to differentiate the multiplication of this 2 times 5, which is 10x squared, and the derivative is 20x. Correct. 1x plus 8x, which is 13x, the derivative is 13. So that's fine, because I don't differentiate the constant. Alright, let's try the next two, please.
You don't differentiate like before. It's like x there, it's x equals 0.
This one's just this one. It's just x take 3 times.
Yeah.
That one's just normal.
See, it's easier.
Yeah, but that one's just normal. That one's just stupid. Oh, get down low. To the big shack door.
So just remember, all these examples I've given you here and the next the exercise that I'm asking all of you to do is to make sure that you have got the speed and accuracy. Alright? Let me unfreeze my screen. Do you agree with my answer? I always, in this sort of situation where you could actually just multiply, I always do a sanity check and make sure that it looks right. So I know that this would be x squared, and we got minus 3x plus 1x. Yep, that's all right. That looks right. Okay. The next one.
Yeah, the last one.
I've got x squared plus 3x, so times 3x. So I've got 3x squared. So I should have a 3x cubed. I should have a 6x squared. So that's fine.
It's wrong.
Multiplied like the 3 times 2x take 4. You derive the x squared take 4.
Hang on. What have I done wrong?
Like the 3 times 2x take 4.
X squared. Why did I do that? Yep. It should be x squared minus 4. What have I done there? Alright, I know what I've done.
It's 9x squared.
It should be x squared.
I don't need the minus 4.
Take 12.
I don't need the minus 4.
Yeah.
Yeah, I don't need the minus 4. That's where I made a mistake. Yep. Alright. The minus 4 is not there. Alright. So that is that's it. Alright, my fault.
No, sir.
Hang on.
It's supposed to be x to the power of 2, not 2x.
2x.
It's x.
Yeah, hang on. It's 3
Times 2x minus 4.
2x.
And 3 times x squared take
3
It's
x,
3.
X squared minus 4, not
Yeah,
2x
yeah,
minus 4. Yeah. Sorry. My fault. I'll sort it out when I
Just write the answer, sir.
My fault. Yeah. All right, next. Here, the graph of y equals to fx and gx are shown on the graph to the right. Now, I haven't told you what fx and gx is. How do you do that?
Solve.
No,
Why not?
not solve.
Why not? It's not
Yes,
that
thank you. Find the equation.
That's
You
what
don't know which one is fx, you
Solve,
don't know which one is
solve.
gx. Doesn't really matter.
It doesn't matter.
You can say one of them is fx. Let's call this
y
fx.
equals
Let's call this gx.
negative
No problems at all.
3x
So now,
plus 5. and
the
then
important
minus
thing
y
is look at the gradient of gx.
equals-
What is the gradient of gx?
2.
2. So gx is 2x minus 2. Correct?
Yeah.
fx, the gradient is, what is the gradient?
Negative 3.
3. Negative 3. So it's negative 3x plus 5. So now you know that p will then be equals to 2x minus 2 times minus 3x plus 5. Hey,
Hey.
can you use your product rule?
No.
Of course you can. I'm the one who made the mistake, not you. You picked up my mistake, so.
I never make mistakes. 12, negative 12x plus 16, and then when
Someone help me with the last question.
dy. Look,
Last
wait.
question.
Why?
Hold up, we're at question 2 now.
Yeah, but only on question
No,
2.
but like, just help.
Just wait. Negative 24. What the fuck am I doing? Plus 16, and that's equal to 8. Last question. Yeah, now have fun with that. I'll do it
Alright.
at the end of this.
So the thing is, you got to be able to use the knowledge you have for linear. In this situation, find the two equations, and then the rest is pretty straightforward. Correct? Negative 8, thank you. Alright, let's go on to the next example, example 3. Find the equation of the tangent line to the curve of this at the point where x equals to 4. Now, what I would do is to rewrite this. That will be equals to 4 x to the power of half times 3 plus x to the power of minus 1. Alright? Make it a little bit more straightforward for yourself.
Oh. 2. 2. 2.
This is a tricky one. Alright,
It's a 3 of x.
now, if you write it out properly, you should have 4 half x, differentiate that first, half x to the power of minus half, times 3 plus 1 over x, then plus minus 1. I always use a bracket because I differentiate that minus 1, x to the power of minus 2 times x to the
3x
power
plus
of
14
half.
equals 3x.
Alright, keep going.
Oh, I didn't solve it way around. I still got it right.
I'm taking the 4 out to make life a little bit easier for myself. I'm not going to concern myself with the 4 yet.
It is. You just took the 4 out. But, yeah, but I don't know. I wouldn't do that. Just keep the 4 in. Just like see.
So you had so you guys like this like that.
Yeah, yeah.
And then you have two different
Yeah.
functions.
Yeah, yeah.
For your
Now, what I've done the next bit is actually I multiply everything in. So that I know I still keep my 4 out. The coefficient, I'm not going to worry about it. So half x to the power of minus 2 times 3 is 3 over 2 square root of x. Right? Next one, x minus half plus times x minus 1. So it's x to the power of minus 3 over 2, which is the denominator, and 2. And then, look, I use a bracket so that I know that there's a negative. So it's minus x minus 2 times x to the power of half. So minus 2 plus half is minus 3 over 2. And you get that. Now, I'm not actually going to simplify that. All I want is to find the equation. So I'm going to start off to find what dy dx is as x equals to 4. 4 times 3, 2 root 4 plus 1 over 2, 4 to the power of 3 over 2 minus 1 over 4 to the power of 3 over 2. Alright? Which will give me 4 times 3 over 4 plus 1 over 16 minus half, which is 5 over 4. Alright? So I know at that point, the gradient is 5 over 4. Now I need to find y when x is 4. When x is 4, y equals to 4 times square root of 4 times 3 plus 1 over 4. Alright?
I rubbed it all out because
Now I work in terms
I was
of,
copying him, but that's definitely wrong.
That's okay.
What did you get?
that is 8
3x
times
minus
he got-
14.
5 over 4.
3 plus 1 over 4.
3x
So I work out
minus
24
14
plus
plus
1 over 4, 8,
But I
4,
don't know
which
if
is
it's
2,
right.
which is 26.
What did you get?
Alright?
I got
So you know the coordinate is 4 and 26.
yeah.
So using y minus y1 equals to m, x minus x1, I have y minus 26 equals to 5 over 4, x minus whatever it is, x equals to 4. So therefore y minus 2 equals to 5x over 4 minus 5. So y equals to 5x over 4
that should be negative.
minus
Minus 2.
20, sorry, it's 26, y minus 26. Alright, 26, 21.
Did you get that?
Alright,
3. Did you get
3.
Yeah.
see the process?
Bottom got 11.
So I find the dy dx first, but I don't actually simplify it. You are not asked to simplify it.
Oh yeah, then you can just set like this.
By not simplifying it, substituting 4 in as x, it makes life a little bit easier. Correct? Yeah? Happy with that?
Oh,
Yeah?
yeah.
So make sure that something like this, don't bother simplifying. You are not asked to simplify.
I'm do it on the cost.
If you find that you got to that point, the answer is still correct. Because by the time you substitute 4 in, makes life a little bit easier because square root of 4 is 2.
Right,
4 to
so
the power of
actually
3 over 2, which is just 2 cubed. Same with that. Right? Rather than filling around and working out the common denominator.
I'm just gonna say he's right.
All right. Next, example 4. How many examples do I have this time?
6.
6. All right. I can't remember.
The values of the gradient.
All right. I'm going to let you work this one out yourself first.
Wait,
What is it? Oh wait, all wrong.
I've been out for all wrong.
Go wrong.
What was it?
Wait, what did you get? What did you?
11 on 4 as a grade.
Oh no, that. Yeah, that's right. That's
I
right.
got y is 11 on 4 x plus 15. But the gradient is 11 on 4, right?
I think so. Yeah.
Right. You think so, or you know?
I know. I know, bro. I know. Don't worry. That's not predictable.
Oh, this is a big
All right.
question. Sir, you've
Have
gone
you
way
found
too quick here.
dy dx?
Not yet.
All right. I'll let you find dy dx first, and then we'll sort something out.
Oh no. No, I made the dumbest mistake. Holy shit.
What'd you do?
All right.
I did
Sir,
something dumb.
Are you going to solve it, or are you going to use your calculator?
I'm gonna solve it, sir. 'Cause
I would say I use calculator.
no
I'm very lazy.
way. So that's too lazy.
Oh no, of course.
So you don't get calculator and calculator free.
This will probably, looking at this, most likely be in the calc assume section. If you've got a calc
No
assume
way.
section, you solve.
Yes.
All right.
11-4. Got it.
Have you got a calculator? Have you got a class pad?
I have my brain.
If not, grab one for me, please. You solve. Now, you're going to solve all this as minus 12. Takes a lot of time, expanding and everything. Yeah? Yes?
Yeah.
I expanded everything, so it doesn't matter.
Yeah, I know you expanded everything, that's fine. But in terms of exam, what would you do? Are you going to expand it, or are you going to use solve?
Expand it.
No, I just did
Come on.
What if it's
It's a calculator assume section, you use your calc.
One on next.
Alright, I'm just going to write down use solve.
That was my mistake. So here, that's supposed to be
Yeah.
1 on x, right? But here I had it
Yeah.
as 3x.
Agree?
Made a mistake.
Yeah.
Agree?
Yeah.
Yep?
Yeah.
Okay, that's fine. Agree with my dy dx?
Yeah.
You solve.
Yeah.
You solve function. Alright, next. This one, determine the expression for the rate of change of the following function. Do not simplify your answer. Can you try that, please?
Oh, you just.
Alright? Do not simplify your answer.
Oh, right.
You use class pad?
Yeah. Oh, why is there a 3 there?
Yeah, so use thing we did last lesson. Product chain rule.
So you put the chain rule and then the
Now, here you've got the product rule and the chain rule combined. Alright? When you differentiate this 1 minus x squared to the power of 3, you need to use your chain rule. Thank you.
Bro, remember the chain rule? It's like because you have product rule, you get the You got a differentiation of 1 and then just leave the other right. So when
Now
you're
this is the
differentiating
combination
the
that you
second
need to
one,
know. The
you
product
gotta use
rule
the
and
3
your
here, 3, 1,
and
2,
your
take one off the power and
chain
then times
rule.
it by the
When I say do not simplify your answer,
from
means
that.
you don't actually have to expand it. But still, there are certain things that you need to do, alright?
But how do you?
There's still certain things
You don't have
So I
to
differentiated that.
Don't you already have the
I
differentiation?
did the chain rule.
Sorry.
Don't you already have the differentiation?
No, you don't.
What do you do with the other thing? Like I did the chain rule here. What do
Yeah.
I do with this?
So you just times it by the other one. So you, because you use a product rule, right? So you
Not to simplify, but you
differentiation
still
of the
have to
first one
add
times the
3
second one,
three times
then
minus two.
differentiation of the
You have-
second
you still
one
have to
is
do
the
that.
chain rule times the first one.
Wait, so
Because you have two functions. Yeah.
But you times it by the differential of this. You times it at
Wait, so this one, you get the different
Times it. And then from there you times it by the first
times
function.
this.
Yeah, by the first function. Remember, because in the product rule, you go times differentiation by the other one.
Yeah. So this is the differential.
Of this, yeah.
But then how do you times this with the differential of this?
You're not supposed to, you just times it by that.
Yeah, but you have times both.
Yeah, so then you add the differentiation of that times that.
Yeah.
Alright,
Oh, and then
I'm
you
going to
just
show you my answer.
Yeah.
You use class, but yeah.
I mean, yeah, but you don't have to simplify it. So
You don't simplify it, but
just leave it like that.
you still have to multiply those two.
just leave it
3
at
times
Yeah.
minus
Well, that's
2x,
what
you
it
still
said,
have to show me is minus
Just
6x.
do not
Alright?
simplify your answer. So.
When I say don't simplify, you don't actually have to expand it. Alright? But you need to be able to multiply 3 times minus 2, which is minus 6x. So, what I've done here, I have actually started off by doing the differentiation of this. Alright?
6 squared, it should be 6.
And then 6 square, of course, sorry, 6 square, and then times whatever it is. 6 square plus 1 times the second function. And then this one here, you need to use your chain rule. Differentiating this, 3y minus x squared to the power of 2, and then 3 minus 1 is 2. And then differentiate what's inside, which is minus 2x, multiply by that. Alright? So you need to be able to combine those two. 3 times minus 2x makes it 6x. Do not simplify. Don't worry about expanding it. Last question, last example is actually, I would say, the hardest. How are you going to do this?
Have you got it yet?
No.
How are you going to show that that derivative is this?
You don't.
Yes, you can. So what I like to do in this situation,
Rewrite.
Just leave that.
I actually rewrite this equals to x to the power of 1/3.
Just says don't simplify, so you don't need to expand it all out.
1/3.
But
what am I
simplify
doing?
seems expanding.
Let's get rid of that.
Yeah.
Y equals to x to the power of 1/3.
Yeah.
And times, put a bracket in, 2x minus 1 to the power of 3. Alright?
I guess it's like an addition.
From there, you should be able to use your chain rule and your product rule.
Okay.
First look at this, and do not touch that. Then don't touch this, differentiate that. Alright, I'll let you play around with it.
Yeah. So.
How do you get to the How do you get them to multiply? Because I'm doing the product or the. I get to this, right?
Yep.
Then you have the addition here. So how you
Plus?
Yeah.
Ah! I will show you in a few minutes. Alright?
Okay.
There's a trick to this.
But I won't tell you which row.
You've got to recognize the common factor. How do you factorize? What is the common factor there?
2x minus 1.
Think about it again.
Or
Thank you.
what is it? Oh yeah. Okay.
The common factor
You
is,
silly goose.
it's not, it's experience.
Yeah.
Yeah, but if you're adding them.
This question is not easy. See how many times
Yeah,
I
but
have
if
to
you're adding
scratch
them, you
out.
can still factor it.
Alright?
If you're adding them,
I'm going to
you can
scratch out a whole
factorize
page.
it.
I was so careless when I was working that out last night. That was really
Oh, yeah,
interesting. I
yeah.
love this sort of question.
And then on the next, you just have to agree with your to make that bracket 6 and take it out.
Now, very first step, you got up to here, correct? What you need to think about is use the answer to help you. The answer says there's 2x minus 1 squared. Look at this. Hey, here there's a 2x minus 1 cubed, there's a 2x minus 1 squared. So what is it? What is it telling me? These two terms have a common factor. Correct? Now, that means it's telling you you have to take it out first, factorize it first, and then simplify it and bring it back to there. Right? So if you simplify it, you take the common factor out, is 2x minus 1 square. So this term therefore become 1/3 x to the power of minus 2 over 3. And then that is multiplied in as 2x minus 1. Yeah? Happy with that? Then, plus this term, I've taken the 2x minus 1 out, factorizing it. 3 times 2 is 6. 6 to the power of, have I missed something? 6 to the power, 6 x to the power of 1/3. Yeah? See that? So now I've established one term there. Right?
Yes.
Always when you look at exam, use the answer. If you got to prove it, use the answer to guide you. So the answer is giving you the hint that 2x minus 1 squared is one of the factor. So from there, I'm just going to leave 2x minus 1 squared, and I'm going to write this as this format. Right? So you can see that that is here,
That.
which is cube root of x squared.
Yep.
X to the power of minus 2 over 3 is cube root of x squared. So here I've got 3 cube root of x squared, and this will be 2x minus 1. And I still have 6x to the power of 1/3. Now, next bit, bring everything to the common denominator, which is 2x minus 1 squared. Common denominator, 3 times cube root of x squared, 2x minus 1. Now this time, 6. Let's do x to the power of 1/3. And I've got 3 cube root of x squared, which is x to the power of 2/3 times 3. Correct? 3. Yeah? Do you agree with me?
No, yes.
Yeah? So I've got to change that here. The reason I'm writing this x to the power of 2/3 is I want to see what I'm getting here, which is x 1/3 plus x to the power of 1/3 times x to the power of 2/3 will give me x to the power of 1. Right? So therefore, I now have 2x minus 1 squared. here, I can write it as a common denominator, cube root of x squared, 2x minus 1. So that is x, 3 times 6 is plus 18x.
Probably would not get that exam.
So therefore, that is 2x minus 1 squared
Be that question to skip.
times
Yeah.
times 18x plus 2x is 20, x minus 1 over 3 times cube root of x squared. Yeah. Things like this in the exam, you've got to be able to use your answer to guide you. Alright? So here, the hint for you is once you've got up to this point. Getting up to this point is straightforward because you know your product rule and your chain rule. Then observe that this is basically, that bit is your factor. Take it out and then start simplifying it. Use what you have learned, how to get to the common denominator and everything so that you can prove it.
Essentially one when you cancel it out, yeah? So that gives you, yeah.
Alright, this is probably one of the hardest example I have for you today, and I'm going to finish off the lesson now. So, actually, just a quick one, just an extension if you want to know. If you've got 3 functions, dy, dx, and it's just an extension, alright? It's for you to just look at. You don't really have to know it. So you've got u, v, w. So the first one is du, dx. The other 2 functions will be the same. And then use the middle one. Take the derivative of that one. And then the derivative of the third one. Multiplied by the 2 functions. That's all. It's something to let you know, just for you to, just to show you. You don't really have to know that. So this is a waste formula sheet. You should have it. You don't have to memorize it. You should be able to refer to it. But however, once you've done the exercises, you should be proficient enough not to actually look at the formula sheet.
Sir,
Yep.
do you have any more questions like this one?
Right, let me finish this off.